Okay, we're going to do a quick review of what we talked about in class today. So what I'll do is I'll work on the back side so you can kind of see the answers. I figured this actually be a good way to make sure you actually tried it and then check your answers. So first thing, what we're talking about is Wheel of Fortune. If you ever watched it, it's got the bankrupt on the wheel. What you find out is there's actually a 1 out of 9 chance of you getting bankrupt on the wheel. So what they're saying is of all the spots on there, 1/9 of them are filled with bankrupt. We're going to say that Pat Sajak observed a random sample. So that's the important part of 50 spins and found that bankrupt was spun 10 times. This is convincing evidence that bankrupt comes more often than it should. So we're going to do a simulation. So if you think about it, what we're saying is that 1 out of 9 times it's bankrupt and 8 out of 9 times it's not bankrupt. Okay, so what we want to do is this is very similar to the way we selected a sample. What we're going to do is we're going to assign numbers to the simulation process. So what I'm going to do is I'm going to assign the number 1 to bankrupt. And I'm going to then assign the numbers 2 through 9 to not bankrupt. And if you think about it, there's only one thing I want to ignore here. I'm going to ignore 0. I'm okay with repeats because you could spin the wheel and get bankrupt multiple times. So it's like once you spin bankrupt, they don't take it off the wheel. You keep spinning it. And now what I'm going to do is I'm going to use some sort of random number process. So for example, I could say I'm going to use a random number generator. Or I'm going to use a calculator or a computer, and what I'm going to do is I'm going to generate a 1-digit integer and basically determine if it's bankrupt or not. So what it means is if I get 0, it means I got to do another random number because I'm ignoring that. So I want to keep doing that process. So this is a process for one time. And what I'm going to do is I'm going to repeat that process a total of 50 times. So I'm not sharing my screen. That would be a problem. Okay, so let me walk through again. What I'm going to do is 1 out of 9, we're talking bankrupt. 8 out of 9, we're considering not bankrupt. I'm assigning 1 to bankrupt. I'm assigning 2 to 9 to not bankrupt. And I'm ignoring 0. I'm going to use a random number generator. I'm going to generate a 1-digit integer and determine whether it's bankrupt or not. I'm going to repeat the process for a total of 50 times. So that's basically how I'm doing the simulation. So again, I'm doing a simulation. So what I did below is I did 100 simulated trials of 50 spins on a fair wheel. So if you look down below, what ends up happening is this would be 100 different times of spinning the wheel 50 times. And then the counting how many bankrupts I got, anywhere from 1 to 12, 1 to 12 out here. So what one of the dots above the 12 means is that represents 50 spins of the wheel. And count the number of bankrupts. So for example, that guy right there says spun 50 times, spun 50 times, got 12 bankrupts. So in this case, now we can answer the question, do we think the wheel, is there an issue with the wheel? If that bankrupt comes up, 10 out of 50 would be too much. Because again, do you think 10 or more would be too much? Well, again, let's take a look and see in my simulation how many times that happened. Right there, that says 4%. So that's saying 4 out of 100 of these trials. So 4 out of the 100 trials, or 4% of the time, I got 10 or more bankrupt. Since that's less than that 5% magic number we have, it's statistically significant. What that means is the following. Something may be up with the wheel. Something may be up with the wheel. That does seem unusual. In this, we would have convincing evidence that bankrupt came up more than it should. More than it should. Okay, again, the magic number is always 5%. 5% is kind of our tipping point. If something happens more than 5% of the time, that's not significant. Basically, what it would be saying is if I had done the simulation and I had come up with that 8 times out of 100, bankrupt came up 10 or more times, I would say not a big deal, because again, it happened 8% of the time in this simulation by random chance. Since it's less than 5%, this is when we're talking statistically significant. So that's the first part. The first part is we talked a little about simulation. We talked a little bit about statistically significant again. So, okay, good. Next part, because we did this after the banana one. This is the check your understanding on this. So Pew Research reported that among mothers, family size is shrinking. Suppose we were to randomly select one mother, age 40 to 44, and record the number of children she has. Here's a probability model. Okay, again, let me talk about probability model. First thing, every one of these values here should be between 0 and 1. So the first thing is I know that each one of these should be somewhere between 0 and 1. They all are between 0 and 1. So that's the first check. The second check is I need to add them up and make sure that they add up to 1. So 22 and 41 is 63. 63 and 24 is 87. 87 and 13, that gives me 1.00. That's 100%. So that tells me it's a valid probability model. So when it asks explain why, I would say that each probability is between 0 and 1. And all the probabilities sum to 1. Okay, so that's the first piece. The other thing we talked about today was mutually exclusive. Mutually exclusive means two things that cannot happen at the same time. So you're going to see the word mutually exclusive, or occasionally you're going to see the word disjoint. They mean the same thing. So when you see mutually exclusive, when you see disjoint, it's talking about the same idea. So now explain why the events have one child, have two children are mutually exclusive. Basically, I can't have exactly one kid and have exactly two kids at the same time. Okay, so that's what that is. And again, sometimes you'll see it referred to as this, the probability of A and B. That's how we read that. The probability of A and B equals 0. So the probability of having one kid, exactly one kid, and exactly two kids is 0, because you can't do it at the same time. The rest of it is, can you read from the table? So this is a little similar to what we did back in, I think it was chapter 1 and 2. Find the probability a randomly selected mother has less than 2 children. So if you have less than 2 children, that is the probability. If I said the probability of less than 2 children. Well, there's another way to think about that. That is the probability of having one child. Because according to the table, to have less than 2, it's only that. So in this case, the probability of one child is 0.22%. Next one, find the probability that a randomly selected mother has 1 or 2 children. That's different than this and. That is saying the probability of having 1 kid or 2 kids. Okay, you'll oftentimes see it written like this, probability of 1 kid, and then we say the union 2 kids. Well, we already said that those are mutually exclusive. So what I'm allowed to do is I'm allowed to say that that's the probability of having 1 kid plus the probability of having 2 kids. Because there is no overlap, I can just add the 2 probabilities together. 0.22 plus 0.41 tells me I got about a 63% chance of having 1 or 2 kids. And then find a probability that a mother does not have 4 or more children. Okay, does not. That's the word complement. So again, we're going to talk about the idea of complement. Complement is typically implied when I use the word not. So in this case, probability of not having 4 or more children, you would say 4 or more. And then we would say not. That's what that little C means. Complement means not. Oftentimes what you'll see is you'll see something along this line. You'll see like event A equals have 4 plus kids. And then it'll say, so probability of A would be saying, what is the probability that I have 4 kids? So in this case, the probability that you have 4 kids is 0.13. This one's asking you the probability that you don't have those kids. And the way you do that is it's a subtraction. It's 1 minus that probability of A. It's 1 minus 0.13. It's 0.87. So that's my complement rule. And I'll be honest with you, oftentimes complement rule will give you the quicker answer than not. So that's what we talked about today. We did some stuff with some rolling some die to practice some stuff. So hopefully if you were here, you got something out of it. Give me the feedback in the reflection, and I will see you all next week, and we'll keep going with the probability. So thanks.